Hello everyone, I am Dr. Sirajul Faizi. I welcome you in my YouTube channel. Today in this video, I am going to talk about analytical chemistry. You know, the analytical chemistry is the branch of chemistry which deals with the analysis of substance. It is mainly divided into two parts, qualitative analysis and quantitative analysis. So, what is qualitative analysis? Qualitative analysis, my friend, it is primarily concerned with the identification of the constituent present in a chemical substance or mixture of substances. What is quantitative analysis? It is a primarily concerned with the exact determination of the quantity of constituent present in a chemical substance or mixture of substance. So, let us start from the scratch. What is the volumetric analysis? Volumetric analysis is also known as titration analysis. Volumetric analysis is a mode of quantitative analysis which is based on the determination of the volume of a solution of known concentration standard required to react quantitatively with a solution of the substance to be analyzed. The process of finding out the volume of the standard solution required to react completely with a known volume of solution under analysis is known as titration. So look at here the apparatus needed for the titration, and this is very important for the laboratory. If you are entered in chemistry laboratory, first you have to arrange all these glassware in your bench. Your bench should be tidy, it should be clean. You have to be with proper dress, like you have to wear apron, you have to wear your safety glasses, you have with your shoes, your hair should be tied, and all your glassware which you are using to perform this experiment should be clean. So look at here, this glassware is known as pipette. Pipette, first you check it is not broken anywhere. Don't use your mouth to take any chemicals with the help of pipettes. Now you can see the iron stand, it should be clean. Now you can see the burette. You have to clean burette properly. If you are not using clean burettes, then you will not get the proper results. Now you filled with the sodium hydroxide solutions, and sodium hydroxide solutions, if you can take in the burette, so check the stopcock. Stopcock, if it is not working properly, check it. Check the proper burettes. Now you can see the measuring cylinder you use in titrations. Conical flask, look at here, this is also known as Erlenmeyer flask. Now you have the sulfuric acid, you have the phenolphthalein indicator. Now white paper you can put on the stand plates so that it is very clear to your eye. When the color change, you can observe easily. Now equipments and the name of equipments. The key equipment used in titrations are burette stand, measuring cylinder, white tiles used to see color change in the solution, pipettes, pH indicator, and conical flask. My friends, before performing the titration, you should keep some important terms which is related to volumetric analysis in your mind. First, titrate. What is the titrate? The substance to be determined is termed as the titrates. What is titrant? The substance of known concentration is termed as titrants. What is titration? The process of determining the volume is termed as titration. What is end point? The point at which the reaction is complete is termed as the end point. What is indicator? Some auxiliary substance. Auxiliary substance, you understand what is the meaning of auxiliary. So, which is used to detect the end point of the titration is termed as the indicator. What is the standard solution? The solution of known concentration is termed as the standard solutions. Now, I will talk about the primary standard and then I will talk secondary standard. This is very important for you, and almost in all general competitive exams they are asking some compounds it is primary standard or secondary standard. So primary standard means what? A standard solution can be obtained by dissolving a definite weight of a substance having purity. Having purity is very important word here. Purity called a primary standard in a definite volume. Now, what does it mean of the secondary standard? A secondary standard is a standard that is prepared in the laboratory for a specific analysis. It is usually standardized against a primary standard. So, if you look at the compound sodium carbonate, they will ask it is primary standard or secondary standard. Of course, primary standard. And sodium hydroxide hydrochloric acid, it is coming under the category of secondary standard. So my friends, again, some important definition you should know before entering your chemistry lab for the titration. Concentration term in volumetric analysis. In volumetric analysis, the various concentration terms are used. Normality, molarity, molality, weight percentage, equivalent weight, and strength. So all these three terms keep in your mind. Normality, molarity, molality, weight percentage, equivalent weight, and strength. Now classification of titration. You know there are different types of titrations. Commonly we are using acid-base titrations, redox titration, precipitation titrations. So what does it mean for acid-base titration? When the neutralization reaction is involved, then the titration is termed as acid-base or neutralization titration. Look at example sodium hydroxide and HCl. What is the redox titrations? How you will identify the redox titration? These are the involving oxidation reduction reaction. How you will find the oxidation reduction? On the basis of basic knowledge what we have learned in 10+2. Look at here, Fe2 plus, it is converted into Fe3 plus. Here you can see the plus 7 2 plus 2. So what will happen here? Redox reaction. So this type of reactions, if you are performing, so this is the redox titration. Now precipitation titration. This is also very important term. These involve the formations of the precipitate. Precipitation of silver cations with halide is widely used in this analysis. Look at here silver nitrate, when react with the sodium chloride it gives silver chloride precipitates. So this is also a very important methods of titration. Now complexometric titration. When formation of a stable complex is the reaction involved, certain organic reagents such as ethylene, diamine, tetraacetic acid, we called it EDTA, forms a stable complex with various metal ions and is thus used for analysis of these metal ions. My friend, we have to know the non-aqueous titrations. What is the non-aqueous titrations? When the reactions occurs in non-aqueous solvent, it means organic solvent, and this is mainly used for analysis of very weak acid and bases. What is the meaning of diazotizations? These titrations involve the diazotization reactions. So look at here the acid-base titrations, very nice pink color. So acid-base titrations, the reaction between the acid and bases are termed as neutralization reactions. This reaction takes place rapidly and it becomes possible to find equivalence point of such titration. Hence, such acid-base titrations have been possible. It has been possible to divide this titration into acidimetry, alkalimetry. What is the acidimetry? The titration of substance which act as base under the conditions of titration with a standard acid are termed as acidimetry. What is the alkalimetry? The titration of substance which act as acid under the condition of the titration with a standard base are termed as alkalimetry. So in acidimetric alkalimetry, the reaction involved neutralization with the formation of salt and water. Now I will focus on acidimetry. You know, in acidimetry, a known volume of alkaline substance or base is put into a conical flask. Now you know the shape of conical flask. And this solution is then titrated against a standard solution of an acid taken in a burette till the equivalent quantity of acid is added to the alkali. The point at which the acid base are added in equivalent amount is termed as equivalent point. You know, if the both acid and alkali are a strong electrolyte, the resulting solution would be neutral and it has pH 7. On the other hand, if acid or base or both acid and base are weak electrolytes, the salt formed get hydrolyzed to a certain extent and the resulting solution would be slightly acidic or alkaline at the equivalence point and the pH will not be 7. So keep this theory in your mind when you are performing titrations in the laboratory, especially volumetric titrations. Now what is the meaning of alkalimetry? In alkalimetry, a known volume of acidic substance is taken into a conical flask. This solution is then titrated against a standard solution of an alkali or base taken in a burette till an equivalent quantity of alkali or base is added to the acid. The point at which the acid and base are added in equivalent amount is termed as the acid equivalence point. The pH of the resulting solution will be 7. If both acid and bases are a strong electrolyte, the pH of resulting solution will be less or greater than 7. If acid or base, both acid and base are weak electrolytes. So, what is indicator? My friend, acid-base indicator. These are the indicator which are used in acid-base titration to locate their equivalence point. And these indicators have one color solution while an altogether different color in alkaline solution. The color change of an acid-base indicator is not sudden but takes place within a small range of pH value, and this range is called the pH range of an indicator. Look at here, a lot of indicator like methyl orange, methyl violet, bromophenol blue, methyl red, litmus, bromothymol blue, phenolphthalein, alizarin yellow. And their color in acidic side yellow, yellow, red, 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 yellow, colorless yellow. The range of color change and color on basic side. So keep in your mind, because if this theory should be in your mind during the volumetric analysis. My friends, indicator used. Acid-base titration is performed with the bromothymol blue indicator when it is a strong acid and strong base titration. A phenolphthalein indicator is weak acid and a strong base reaction, and methyl orange indicator for a strong acid and weak base reactions. So if the base is off the scale, that is a pH of 13.5 and the acid has a pH greater than 5.5, then alizarin yellow indicator may be used. On the other hand, if the acid is off the scale, that is pH of less than 0.5 and the base has pH less than greater than 8.5, then thymol blue indicators may be used. So the method is also very important. An acid-base titration using phenolphthalein as indicator. The conical flask contains solution that just reached the end point. Before starting titration, a suitable pH indicator must be chosen. The equivalence point of the reaction, the point at which equivalent amounts of the equivalent amounts of the reactants have reached will have a pH dependent on the relative strength of the acid and base used. The pH of the equivalence point can be estimated using the following rules. You know the strong acid will react with a strong base to form a neutral pH solution. A strong acid will react with the weak base to form acidic solution, and weak acid will react with a strong base to form a base. Now, methods when a weak acid reacts with a weak base, the equivalence point solution will be basic. Keep in your mind. If the base is stronger and acidic, if the acid is stronger, if both are of equal strength, then equivalence point will be neutral. However, weak acid are not often titrated against weak bases because the color change shows with the indicator is often quick and therefore very difficult for the observer to see the change of color. The point at which the indicator changes color is called the endpoint. A suitable indicator should be chosen, preferably one that will experience a change in color and endpoint close to the equivalence point of the reactions. Now, first the burette should be rinsed with the standard solution, the pipette with the known solution, and the conical flask with distilled water. Secondly, a known volume of the unknown concentration solution should be taken with the pipettes and placed into the conical flask, along with the small amount of the indicators chosen. The known solution should then be allowed out of the burette into the conical flask. At this stage, we want a rough estimate of the amount of this solution it took to neutralize the unknown solution. The solution should be let out of the burette until the indicator changes color and the volume on the burette should be recorded. And this is the first titration volume and should be excluded from any calculations. So my friends, at least 3 more titrations should be performed, this time more accurately taking into account roughly where the endpoint will occur. The initial and final reading on the burette prior to starting the titrations and at the endpoint respectively should be recorded. Subtracting the initial volume from the final volume will yield the amount of titrants used to reach the endpoint. The endpoint is reached when the indicator just changes color permanently. Look at here, an acid-base titration using phenolphthalein as indicator. The conical flask contains solution that just reached the endpoints. So titration of weak acid. The pH of weak acid should being titrated with a strong base solution can be found at different point along the way, and this point falls into one of the 4 categories: initial pH, pH before the equivalence point, pH at the equivalence point, and pH after the equivalence point. So my friends, the pH of weak acid solution being titrated with a strong base solution can be found at different point along the way, and this point falls into one of the 4 categories: initial pH, pH before the equivalence point, pH at the equivalence point, pH after the equivalence point. So look at here, initial, before equivalence point, and after equivalence point. X-axis is your volume of titrants and the y-axis is the pH. So I hope this video will be helpful to you. If you like this video, then subscribe my channel, and thanks for watching.